So as a summary, I like to say that NanoHub and NCN is changing a couple of things. Is changing the sharing of information. Really, these tools are a new publication. It's a new venue for you. You get your work out and to be useful. It's a new way for you to have your own simulations be validated, where people can really see, is this what comes out, and what if I compare this against my simulation, right? It's really aware of sharing and getting the word out. Hopefully, we're really changing the expectations of experimentalists and educators. The idea really is to make simulation useful for those folks, rather than, oh yeah, that's the theory guy. He has a nice toy and that's fine. Certainly, we have changed the pace of tool deployment. There's no other site like us that has that many tools online. And cyber infrastructure is really an important new development in our technology portfolio, and we're changing the face of that by really enabling people to share and reach other communities. So with that, I'll take some questions. Yes?
I would like to comment about the target for this kind of web-based computational tool about the community of computational services. I say, is it something that I think will be suitable also for the harder computational people stuff, or is something that will be mainly for experimentalists teaching, so a sort of make it easy calculations?
Mm-hmm. So the comment or the question is, can this be useful for computational scientists, right? So I think it can, and I think it is to a certain degree already. I consider myself a computational scientist. I think it's essential that I put my material on the NanoHub to be validated. I can run my simulations through NanoHub environments. All of my students are working on it to develop their own codes through NanoHub technology and with NanoHub technology. Some students work on the back-end machine directly, but whenever possible, I try to also be the guinea pig of making sure this actually can work for computational scientists. And the motivation really is that it could be easy access to cycles, easier access to cycles. You don't have to write your own grants to get onto a machine that can deliver those cycles. Number two, I think if computational science is supposed to be the third leg of science next to experiment and theory, it better start to grow a little bit in terms of being validated, being able to be validated, because part of an experiment is that you put your processes and your to process for experiment down in a paper, and somebody else can duplicate it. But most computational science is not duplicatable right now, right? I mean, nobody or few people publish their code that actually generated this, right? And if you've ever written a code, there's so many little quirks, so many if statements on tuning of some parameter that you know nobody else in the world can possibly duplicate this. If it's not duplicatable, it's not science. Okay? So if computational science wants to fess up and be science, it needs to be duplicatable, and we need to find venues for people to share their methodologies in a way that's open and duplicatable. And this might be just a venue to do that. So, sorry, that's a long answer of why it...
I also think that something that very useful in this vision of this stuff is that make it also much easier comparing various softwares, because usually there is just a few in which you are very skilled, you are hands in, but you don't compare usually so much because it's too difficult learning deeply many softwares.
I mean, from my personal experience, it allows me to run codes like Abinit that I would never run, right? Because I just don't have the time to learn all of the quirks and intricacies of ab init as an ab initio calculation, but I know I need to get my feet wet into it if I want to do atomistic type simulations.